I'll get the light. So in the last lesson, we learned how to use Pascal's triangle to expand. But of course, one disadvantage with the triangle is, if you have a big power, like power 9, you have to go all the way down to the 9th row. Instead, we'd like a better way to make the 9th row, or the 10th row, or whatever. So before we do that, just some new definitions, some terms here. So just to start, has anybody heard of, or does anybody know this factorial? So it's written like this, n factorial. Yeah, some people know that. So 3 factorial is 3 multiplied 2 multiplied 1. Yeah. 6. And 4 is 4, yeah. Beautiful. 24. This is 2. 2 by 1, which is 2. This one? 1. And this one?
1.
Yes. It seems strange, but just be careful with that. The last one here is a bit strange. Anyway, this is called factorial, so can you just write this down? This is factorial. And you have this on your calculator as well, which I'll show you. Can you see that okay? Yeah. Yeah. Now, every calculator has a factorial button, or at least every science calculator. Yeah? Guys, come on. Every science calculator should have it. Can you just take a moment to look at your calculator and find a button that looks like this, factorial button, on your calculator? No. Or X, yeah, that's fine. It's an X, is it?
Yeah.
Test it out. No. Show me. Yes. Under the mode. Up the top here. Did you find it? Check it. Type in 4 factorial. Guys. Did you find... No, that's okay to use. Did you find it? Yes, on your calculator? You have a calculator? Oh.
I have a ruler.
Oh. You have a calculator? Did you find this button? On mine it's up here, can you see? So if I type in 4 shift factorial, I should get 24. Okay, good. Next, something called binomial coefficient, or nCr. Also sometimes written like this. And for the Chinese students, you write it like this. Here, we always put the bigger number on top when we write it. Okay, so this, yes, this, no. Okay, Chinese students, you'll have to learn to adjust. Now, what is the definition of this function? So, if you have nCr, that is simply n factorial or factorial n minus or factorial. Let me give you an example. Let's say I have 5c2. That will be 5 factorial, 2 factorial, 5 minus 2, 3 factorial, which will be 5, 4, 3, 2, 1 over 2, 1, 3, 2, 1. Now, cancel 10. 10. But your calculator, listen, your calculator has this button. Watch. On my Casio, I can type in 5, shift, and the C is here on mine. Here.
Oh yeah.
5C2 equals 10.
Yeah.
Yeah. So again, can you take a moment to look at your calculator and try to find the C button? Did you find yours? Yep. Yeah. Sarah, did you find it on yours? It might be on the divide. Huh? Let's see where it is on yours. It's on the divide button. If you look on the shift and divide, can you see where it says on the top of the divide button? Lee, you found it? KJ and Jerry, did you find it?
Yeah.
On it, yeah? You found it on yours? Jonathan, you have it on your calculator? Can I see which calculator do you have? And it has it, yes, okay. Hanukkah, no calculator? Yeah, maybe you can just show her where it is on yours then. Yeah. So sad.
I have already.
You'll need to get used to using one. Okay. Listen. So, now that you found that, I want you to calculate the following on your calculator. If you don't have a calculator, you can just do it this way, the long way. Or you can use your neighbours. Your choice. So I want you to calculate these, please. 4C1, 4C0, 4C1, 4C2, 4C3, and 4C4. Yeah. Got those 5 calculated? Yeah. You don't have a calculator, so is she doing it for you? Is she doing it for you? Yeah. You have it done up here? Yeah. Okay, so what's the first number? I'll just show you as an example. 4C0, no. 4C0, you should all get 1. And then if you just go back, 4C2, what did you get here? 4, was it? 6, this is 4, and this is 1. Does this look familiar? Yes. This is actually row 4 on Pascal's triangle. So this means if you wanted row 9 very quickly, you can just do this. Quicker, finishing on 9C9. But if you're smart, you realise, you don't have to do them all because the first and the last are the same, yeah. And they're also 1. And the second and the second last are also the same. So if you have 9, how many do you actually have to calculate? I think it's only 5 of them. That's much better than what you were doing a moment ago, where you had to do row 1, 2, 3, 4, 5, 6, 7, 8, 9. I think you all agree. Yeah. So, using this new function on the calculator, let's have a look at some examples. Now, they can get quite difficult, so you need to pay attention. I'll start with a simple one to begin with.
Yeah.
So, we'll do a power 4 as an example. So, using... Oh, and by the way, the name of this rule, this technique, this method is called the Binomial Theorem, which is also the name of the lesson. So using the Binomial Theorem, expand, we'll go with 3x plus y power 4. Okay, are we ready to have a look at this? So, Binomial Theorem is the name of this method. So, which row do we need? Row 4. So, we'll put down row 4 using the calculator. It'll be, firstly, 4C0 gives us the first number. First, second, plus 4C1, first, second, plus 4C2, first, second, plus 4C3, first, second, finally 4C4, first, second. And then here it's going to be 3xy, 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 3xy. And again the powers. So we'll have 4, 3, 2, 1, 0, 0, 1, 2, 3, and 4. So using the calculator we can get each term. So the first one, if we look here carefully, will be 4C0, alright, 4C0 times 3 power 4 times 1 power 0. The reason I'm saying the 1 is because it's like we have 1y. It doesn't really matter because 1 is still 1, but in case it's not 1, I'll show you what to do. So it's like there's a 1y here and a 3x. So we have here 4C0, 3 power 4, 1 power 0. And if we hit that in on the calculator, the first number is 81. 81 x power 4. The next one, the only difference is if we backspace, this is a 1, this is a 3, and this is a 1 now. So the next one is 108 x, just Sean now, correct, y, okay. Next, the only difference is we've moved on to 2. So that's a 2, that's a 2, that's a 2. So the next one is 54 x squared y squared. Plus the next one we're on to 1 now. 3. 3, 1, 3, 12. And finally, the last one is 4s. 4, 0, 4, 1. And that's the expansion of 3x plus y power 4, is all of this. Okay. So we'll do another example now, making it a little bit harder. Just so you have a bit of vocabulary, these numbers 81, 108, 54, 12 and 1, they have a name. Does anyone know their name?
Number.
Very good. Not number, you know. Coefficient. Okay, write this down. We'll have a look at another example now. You have this? Okay. Next example now. So for this next example, I don't need to expand the whole term. I just want a particular term. So for example here, what is the x cubed coefficient in 2x plus 3, well, let's make it a minus, 2x minus 3 power 5 or something like this. So I don't want the whole thing here, I just want the x cubed part of the answer. So it's not necessary to expand completely. We just want to pick in on the x cubed part. So how can we do that? Well, first we need to think about what row we want. So what's going to happen here is we're going to skip the ones at the end. We're going to jump straight to the cubed one. And then we're going to skip the ones after that. And I'm just looking for the number that goes on the x cubed. Well, let's try and find that. So we know that it will be like this. There'll be a C, there'll be a bracket, and then it will continue. We know what will be in this bracket. 2x. And what will be in this bracket? Minus 3. Now if we think about it, we know some of the numbers already. We know what this number will be. 5. Because we're on row 5. And actually, if you think about it, we know what this power must be.
3.
Must be 3. Which then forces the other power to be 2. Now what about this one here though? Oh, I love that I heard some people say 2 and some people say 3. In fact, 2 or 3. No, both will be the same. What? 5C2, 5C3. Same. So we can use 2 or 3. It doesn't matter. It's the same. What do we know it's not the same?
No, I mean in other situations.
In other situations, yes. This number here, if it matches one of these, this will be the same. So I'll give you another example. Let's say we had 10C something. Let's say we had x power 8 and this, I don't know, is 4 power. What will this have to be?
2.
It'll have to be 2. And if I put an 8 or a 2 here, it'll be the same. So it doesn't actually matter. I see some non-believers here. 10C8. Okay? Trust me on this one. So, we'll just choose the tray. So you have 5C3, 2 cubed minus 3 squared. That's the answer. Let's calculate it. I've done it already. What is it? 720. No, just 720. Because the word coefficient means only the number on the x, but not the x. So the answer is 720 here. Okay. Can I do another example now? Yeah. Two minutes? For this? No, 1 minute. 1 minute. Now we'll give him 1 minute. Okay, Jerry. I don't think we're all going to wait for you. Thank you. Right, next one. Expand up to the third term in ascending powers 2x plus 3 power 10. Now, this one here, I don't want the full expansion. I only want the first 3 terms. But you have to think carefully. Do I want the first 3 starting at x10? Or do I want the first 3 starting at x0?
0.
And why? Ascending. The powers are increasing. If I wanted you to start at x10, x9, x8, then this word would be descending. Descending. Okay, so here I'm only asking you for 3 terms. The first term will be 10c0, 2x3, and then the next one is 10c1, yeah, 2x3, and then 10c2, 2x3, and I don't want anything else. I just want those 3. Now, powers. What power here? 10 or 0? 0 ascending. And what power here? 10. And 8. Okay, so the first one will be a big number. 59,049 plus 393660. Oh, I forgot my x. Oh no, there's no x. X plus and the last one is 118,0980 x squared dot dot dot, and that's the answer for that one. Okay, write that down. Got this? Lee! Come on.
Yeah.
You're distracting me. Did you write this down?
Yep.
Yep. You have, can I go on to the next example? Okay. So next example. So all the examples we've done so far, I've given you all the information. In the next example now, there will be some information missing. Find P and Q, and I also tell you that they're both positive, if Px plus Q power 6 equals 1 plus 6x plus 15x squared, etc. So in this example, we are going backwards. We have the answer and we want the original question, the P and the Q. Yeah? You got the idea here? We're trying to find P and Q. Okay, so we do this, no, laptop close. Laptop close. Yes, you're the only one with a laptop open. Okay, okay. I lost my train of thought. We're working backwards here. So we're trying to find the P and the Q. So we do what we were doing a moment ago. We expand. Here we'll have 6.
0.
Yeah.
Yes.
And Q. Not minus. No minus. What word did you mean? No, go on, what? Yes? Come on, we're all rooting for you. What word is it? Point. Multiply. Okay. You should remember that. I use it a lot. Yeah. Okay. So the next one, 6c1 pxq, yeah, plus 6c2 pxq equals, and I don't have space, but it's the same thing as this on the other side. Oops. Okay, I have to put in the powers now. So here, what power should I use? Yeah, now why 0 and not 6? Yeah, it's ascending. 0, 6. 2, 4. Yeah. So this will be Q6 plus 6PQ5X. What's 6C2 now? 15. Q4 X squared dot dot dot. That should equal 1 plus 6x plus 15x squared dot dot dot. So here what you do is you compare the left and the right. So this one here must be the same as this. The 6PQ5 must be the same as the 6 here. The 15P squared Q4 must be the same as that one. So we can say Q6 must equal 1 and 6PQ5 must equal 6 and 15P squared Q4 must equal 15. Now this is kind of an easy example here because Q has to equal 1. If I put that in here, I get 6P equals 6. So P has to equal 1. I can stop because I have my P in the Q. But it's good to check. Does 15, 1 squared, 1, 4 equal 15? Yeah. So this is the answer here. And, yes? Yep. Yeah, you see? We knew what he was thinking. I'll remind you, Sean. Okay, write this one down, please. Yeah. You can see?
In the exam, do I need to write all this?
What would you leave out? Like in this example here, like I can't really see a line that I could skip, you know what I mean?
I only write 2 sentences.
2 equations?
Yes.
Sure.
Just 2.
This? Oh yeah, so in this example it's easy to see this and this, but that's only because it's my example. You couldn't just do this in the exam because you would need to, say this equals this, yeah. Now I know in this example you can, it's okay. In this example, but I don't think you'll get it like that in the exam. In the exam it'll probably be something like 64 here, something like that. And this wouldn't be 6. Okay, do you have this? At the end you notice I had 3 equations. But how many unknowns? Only the 2. P and Q. 1, 2, 3. I didn't need 3. I only needed 2. So I could have just told you this and this. I didn't need to tell you this one. But can you think of an example where you would need to know these 3? How could I change this so that you need to know 3? Yeah. If you didn't know the power, then you would need 3, because you would have 3 unknowns. P, Q, and N, the power. They are very difficult. In fact, I think nearly too difficult for the exam, because I've never seen that type in the exam. But I have seen these types in the exam, where you have to find something that's missing inside of it. Okay? In the exam, sometimes there's 2 missing, and sometimes there's 1 missing. I've never seen 3 missing. It's quite difficult to do. But not impossible. Okay? Let me give you some to try now. Let me see. We'll say two C. No, what did I say? Not. Yeah, okay. 1C, 2C, 3 H, 3I, 4 H. Oh, that's a hard one. I like that one. 4I. And 5A. Difficult. Difficult here. Well, look, I sat down one evening and I made all these questions, so I want you to appreciate these questions. You know, these questions didn't just fall out of the sky. I had to, dream these up. The ones marked with the star, these are quite difficult, so you know. I really think you should definitely be able to do the blue ones here. So you might want to start with these ones first, and then do these ones second. Okay, if you can start these now for a few minutes, please. Thank you.